This will be a relatively short presentation on Dalton's law of partial pressure. It's a relatively straightforward concept. Our objectives will state Dalton's law of partial pressures and we'll use it in calculations involving gaseous mixtures. Dalton's law of partial pressure includes vocabulary we have not yet encountered. What is partial pressure? It is the pressure due to a single gas in a mixture. We assume that the gases are not chemically reacting with each other and that they do not interact with each other either. So it could be attractive or repulsive forces. We're saying there are none of those. There will be gas law problems where chemical reactions take place. A whole subset of these problems. There will also be gas law problems where gas molecules do interact with each other. That is a different subset of these problems. So Dalton's law of partial pressure, you assume that you don't have a chemical reaction and you assume that the gases do not interact. Which brings us to Dalton's law of partial pressure, which says that the overall pressure of a mixture of gases is equal to the sum of the pressure of each of the gases. So I've given two versions of the law in the top right corner. The bottom version uses formal mathematical notation. Uppercase Greek sigma means the sum over. I is an integer, 1, 2, 3, etc. N is the number of components in the mixture, and Pi is the pressure of each individual component. So when we have P1, P2, P3 plus ... Pn equals P total, that is summarized with that formal mathematical notation. You can see Dalton's law illustrated in this graphic. If you add up the pressure of oxygen, nitrogen, argon, water, and carbon dioxide, you end up with the pressure of air. These are the main components of air that you breathe. So overall, that's 101.3 kilopascals, which is the same as 14.69 psi, which is the same as 1 atmosphere, which is the same as 1.013 bar. So remember, there's lots of unit conversions possible because there's lots of different pressure units. So let's try a problem where we solve for a pressure using Dalton's law. Discharge from a gas furnace has an overall pressure of 1.1 atmospheres. The partial pressure of carbon dioxide is 0.055 atmospheres. The partial pressure of hydrogen disulfide is 0.022 atmospheres. What is the partial pressure of the remaining air? Okay, so we can write Dalton's law of partial pressures for this particular problem. We're going to have hydrogen disulfide plus carbon dioxide plus air is equal to the overall pressure. So we sum all of these components and then we can solve. We're going to plug in the values that we're given right there, and then we just solve for the pressure of the air. And when we do that lovely subtraction problem, it rounds to 1.02 atmospheres, because remember, when you're doing addition and subtraction, you always go to the least precise place, which here is the hundredths place. All right, so hopefully all of that made sense. To summarize, Dalton's law of partial pressures says that the total pressure is equal to the sum over all of the partial pressures. We can summarize this by using formal mathematical notation. P sub I is the pressure of a gas in a mixture. N is the number of gases in the mixture. I is the gas. P total is the total pressure of the mixture. And the only thing to really watch out for when you're using this is make sure that you have matching pressure units. Otherwise, it doesn't work.